All right. We ready? We ready? We ready? We got 2012, number 1 in front of us. All right, so they want you to estimate W prime of 12. This is going all the way back to the first unit where you use the average rate of change to estimate the instantaneous rate of change. The biggest thing here is to remember that you're doing y divided by x, so it's not the top of the table divided by the bottom. You have to flip those. And then to get your units, you have to have the units here divided by the units there. So you should have had 1.017 degrees Fahrenheit per minute. You could literally write a little degree bubble if you want, but you should probably include the Fahrenheit.
That's 6.1/6.
Oh. On the 12th minute, so you have to write, it did say to interpret the meaning in the context of the problem, so that means a sentence. So on the 12th minute, the water is being heated. Its temperature is increasing by 1.017 degrees Fahrenheit per minute. So you needed a sentence there. For part 2, it says evaluate the integral from 0 to 20 of W prime and then use correct units to interpret the meaning of that. So I did W of 20 minus W of 0, that gives you 16. So from time 0 to 20, the water temperature has increased by 16 degrees Fahrenheit. Everyone okay with that one? You'd probably be fine since there was not a difference between degrees Celsius and degrees Fahrenheit in the problem, but we could look at that when we start grading them. Yeah. The next one says define the average temperature using a left Riemann sum and determine if it's an overestimate or an underestimate. And so you just have 1/20th or 1 over 20 minus 0. And then went ahead and did my left Riemann sum, so 4 times 55, 5 times 57.1, 6 times 61.8, 5 times 67.9. You can't shortcut that because the intervals are not equal, so you really do have to do each of the separate rectangles like that, and you get 60.79. And then because the function is increasing and you're doing a left Riemann sum, that would make it an underestimate. Okay, and then the last one said for the time 20 to 25, find the water of the temperature of W prime of T at T is 25. So, yeah, I got you, whatever. Before I got started, I had to go look at the table and see that at T equals 20, it was 71 degrees. So I've got the 71 to start with. And then you can use the derivative, the function they gave you, to find 20 through 25 to like get your whole temperature all together. So that's 73.043 degrees. Okay, any questions on that one?
What is that? Is that from 20?
This is from 0 to 20 and then 20 to 25. Yeah. All right. So let me go ahead and hand out the student samples. Yeah. Because you can't just figure out the temperature from 20 to 25 and then have the temperature at 25. You have to add all that accumulation of the increase in temperature. So the 0 to 20 had a temperature of 71. So I started with 71 at 20 and then did 20 to 25. Yeah.
For part B,
Uh-huh.
would you have to say that it was increase, like an increase in change? Like, or is it like a change? Watch how much it changes.
I think it's okay because you said positive 16, not negative 16. I think you'd be okay. Any other questions? Okay. So this question was very similar to the last question, but had some parts that were slightly different. Are we ready? So again, to start you off, they ask you to approximate C prime of something, but you don't have an equation to get the correct instantaneous rate of change, so we do the average rate of change and just say that it approximates the instantaneous. And so again, I did y2 minus y1 over x2 minus x1. I used my y units divided by my x units to figure out what my units of measurement were, and I got 1.6 ounces per minute. Here you did not have to write the answer in context, so that's always fun. So we're just done with that one. For the next one, they said, is there a time between 2 and 4 where c prime of t equals 2? And so what I did is, since they were talking about c prime, they weren't asking if there was a y coordinate between 2 and 4. They were asking if the slope could be 2. That's an indicator to me that I should be using the mean value theorem. And so I found the slope between those 2 points, and that slope was 2. So I went through and I used that c of t was continuous and differentiable. That's part of the mean value theorem, so I said that first. On the interval, the closed interval 2, 4, so by the mean value theorem, there's some c. You might, since this is a c of t equation, c is kind of like the y value, you might use k or something instead, like change that letter. I don't know if they'd care about that or not. But there's some c value on the open interval 2, 4, such that c prime of c equals 2. So mean value theorem definitely should be used there. Yes.
Since it tells us in the problem that it's differentiable,
You have to say it's continuous. Yeah. So they will often say that something is differentiable, and it's up to you to say, therefore, it's continuous, and now I can use this thing. Yes. Letter C, so we're using a midpoint sum. And so with 3 subintervals of equal length, so if you wanted to shorthand this, you could have said 1/6 times 2, and then said 5.3 plus 11.2 plus 13.8. You could have done that if you wanted. And so that's 10.1 ounces. So the average amount of coffee in the cup from time t equals 0 to t equals 6 is 10.1 ounces. So you did have to interpret that one in context. And then they give you the amount of coffee in the cup, B of t, and they ask you to use that to find the rate the amount of coffee in the cup is changing when t equals 5. So I went ahead and I found the derivative by hand. And then I plugged in 5 to my derivative, and I got 6.4 divided by e squared, but you really could have left it like this. Or maybe even just plug in 5 with this one and not even multiply the 16 and the 0.4. Probably would have been fine. Any questions?
I got
32 over 5 might be 6.4. You just did yours in fractions and I did decimals for once. Yeah. Yep, so we're good. Okay. All right. So let me go ahead and hand out those students.